Although the human demand for electricity continues to grow, enough solar energy reaches the Earth's surface to meet that demand many times over. At ASU, the challenge of finding new and more efficient ways to harness the sun's abundant energy is the focus of an ambitious, multidisciplinary effort called LightWorks.
The primary purpose of LightWorks is to draw together all the different elements of light-related research across the campus. And I can say from the outset that we do a lot of research at ASU that is related to light. The primary emphasis of what we do is on energy. So we take a particularly aggressive look at how the research that we do, and not just technical research, by the way, also in humanities, social sciences, policy, law, everything related to the way that people use energy, how we can draw all those threads together into the kind of comprehensive package that can address the big challenges that energy faces going forward.
Integral to the mission of LightWorks is the Energy Research Center, QESST, which stands for Quantum Energy and Sustainable Solar Technologies. Funded by the National Science Foundation and the Department of Energy, the center is housed in the Macro Technology Works building at the ASU Research Park. It is an ambitious undertaking that places substantial emphasis on creating opportunities for student research. It also has established critical partnerships with a number of other universities, businesses, and a variety of stakeholders, all directed at attaining a common goal.
So the easiest way to define the goal of QESST is to talk about the terawatt challenge. And the terawatt challenge was first described about 15 years ago when people realized that to supply energy to the entire globe at the same level that we consume here in the United States, we have to deploy massive amounts of energy producing devices. And those devices, they really need to be clean. They can't be polluting the environment. They need to be economical, and so that people can afford to purchase the energy from those devices. And they have to be sustainable, meaning that they don't rely on a limited fossil fuel. And so this idea of producing massive amounts of power cleanly, cheaply, and sustainably is what QESST is all about.
And the primary means of achieving that is through photovoltaic technology.
QESST is devoted to making solar cells more feasible. So solar cells directly convert sunlight into electricity. They're actually a very unique form of energy conversion. So if you look at most of the way you generate electricity, it's all coming from generally a heat source. Then the heat source via a generator gets converted into electricity. So solar cells are completely different from that. They take a sunlight and directly make an electron, and then the electron comes down the wire to be used by whoever or whatever it's needed, the same way that the generator would power it. So it's technically the newest out of all the electricity generating mechanisms.
Hansberg and her colleagues also are involved in the creation of highly sophisticated solar cells that employ technology similar to that used in the making of lasers.
What we have in our lab is called a molecular beam epitaxy system, and that deposits on a certain substrate a single atom at a time to grow very precise, very well-controlled structures. And people have demonstrated, or commercial companies have demonstrated, over 40% efficiency for those types of devices.
An important focus of ASU's solar power labs is to make more highly efficient solar cells that are capable of breaking the 50% efficiency limit.
Most people don't have a very good feel for what efficiency sort of means or what comparable efficiencies are. An old style light bulb used to be about 4% efficient. A conventional electricity generating plant is about 30. A car is about, say, 15. Humans are about 15% efficient. So the theoretical efficiency for a solar cell is actually over 80%. So even though existing commercial devices don't approach that, it actually has the potential to be very, very efficient at converting sunlight into electricity.
In addition to increasing efficiency, helping to make photovoltaic technology more accessible worldwide also is a goal.
The sort of high-level view of the goals is to continue to allow photovoltaics to expand at a very rapid rate. So if you look at the rate at which photovoltaics has been growing, it's adding over 40% new capacity a year. So that's an amazing growth rate, and it means that within a decade that we can use photovoltaics for all new electricity energy. So that means you won't have to, at least from an energy standpoint, build any new coal plants, any new nuclear plants. You can have all the new electricity demand met by photovoltaics or other renewables.
Industry partners play an important role in QESST's efforts to advance the field of photovoltaics. Soitec is an international manufacturer of semiconductor materials for electronics, solid-state lighting, and solar industries.
From the very beginning, we have partnered with ASU. We partnered in research on solid-state lighting material solutions, and then we evolved towards also incorporating solar cells research and materials, as well as device research projects. So for industrial partners being exposed and have a chance also to orient this research is very valuable, because this is something that as a single individual industry partner we wouldn't be able to do.
As QESST and its partners continue their work to advance solar technology, a number of critical social issues must be addressed as well. Among the most important is cost.
You think about where we've come already, and it is remarkable, the pace of development of these technologies and the pace at which we have been able to actually drive down the cost of solar. It was only 5 years ago when solar was at about $4 per watt, or in some cases higher than that. And we've been able to drive it down to where some forms of solar technologies are almost below, or are below, $1 a watt. That's a huge price decline. We've got these technologies to the point at which, you know, many Arizonans and many Americans are starting to put them on their rooftops, and it's pretty remarkable. But it's going to take a very sustained effort to continue to try to drive these technological costs down and to bring them to market over the next 10 years.
It is that sort of sustained effort in multiple areas that has defined solar research at ASU.
We are, in my opinion, almost unique, in my experience, for a university to have the scope that we do to address these problems, not simply as the technical problems, but as social and political, economic problems as well. This all didn't happen by accident. This has all been the result of making some very important strategic investments. And I think we're now beginning to see QESST is a great example of that these investments are bearing fruit.